Hi everyone, I'm Greg, and today I'm doing the second video of Intro to AI. So if you haven't watched the first video, please do watch it as it will help you for the subsequent videos. So for this lesson, I want to talk about some terminologies I've used in the previous video. Before we begin, I'll do a quick recap. Remember that I said AI is simply just math probabilities. We also learned that LLMs, like GPT, they follow this output format where your n plus 1 word is dependent on the context of your query plus your first word, second word, all the way up to your nth word. So I use the word context. Okay, maybe an equal sign here is not appropriate. I'll just use an arrow. Okay, we talked about context, and everything here I've underlined is the context. So what is context? Okay, this is the first terminology. Context is basically like an LLM's memory. It is what the LLMs refer to generate a very relevant response. So previously we used the question, what sound does the dog make? And of course an LLM would respond something like, the dog barks. But if I want to add on more context, I could say, what sound does the dog make? Sorry. Is it the same as a cat? Of course, logically, you would know that the response should differ slightly and there should be some sort of reference to the cat. So the LLM would now differ lightly since the context it understands has changed. So it will provide a response something like the dog barks and does not make the same sound as a cat. So now you could even add in more details like, what sound does a dog make? Is it the same as a cat? And you could add on, the dog has a sore throat. And of course, the response would change even more. Then, like any human being, there's also a maximum to how much an LLM can remember. This is what we call the context window, which is the maximum capacity an LLM can remember things. So I like to use the example of a whiteboard. Okay, but imagine this is a whiteboard where you can't erase anything. You're using a permanent marker. So let's say I have already a full whiteboard, right? If I want to add in this additional information, I'm unable to fit it in, right? So this just gets ignored simply because the whiteboard cannot accept any more information. Likewise, giving an LLM too much information that it can handle, or if the information given it exceeds that of the LLM context window, it simply just means that the LLM cannot accept this info. I also mentioned in the previous video that an LLM generates a response word by word. But in actual AI theory, this term is not widely accepted, but I only use that for the sake of learning as a beginner. But the correct term is to actually use token by token. So this brings me to the next point I want to introduce. How does an LLM measure how full its context window is? It's actually not by words, but rather by tokens. In reality, how a model like GPT understands your query is by breaking it down into tokens through a process called tokenization. So let's say, okay, before we continue, tokens are simply smaller individual subsets of your sentence. So let me give an example to help you understand better. Imagine I have a query or question to GPT. Okay, so I pass in a question. And the question is something like, what are you doing? Right? So this will be broken down into the tokens. What are you? Okay, these are just some examples. And then doing can be broken down into do and ing as two separate tokens. And then the question mark itself is also another token. So this question mark actually helps GPT to understand that, hey, I am being asked a question. So I should give an answer that sounds like a response to a question, right? And also another example is, let's say now GPT gives you a response. It generates word 1, word 2, all the way to word n. And then it ends with a full stop over here. So how does it decide whether or not to end with a full stop, or if it has reached the end of a sentence? Remember I said for every question you pass GPT, and with the words it has output so far, whether or not 0, 1, 2, 3 or n words, okay, it generates this contextual dictionary of possible outputs it can give. So in this case, the full stop itself is also assigned a probability. So if it has reached the end of the sentence, the full stop itself could have the highest probability of 0.91, or it could continue the sentence with something like the, all with much lower probabilities, and so on. I've been using the term dictionary, but I want you to know that it is just for the simplicity of understanding now. And as we continue in the videos, I will tell you why that in reality is not really a dictionary, as I delve deeper into how transformers and neural networks work. And that's all. Okay, so after this lesson, I hope that we use the correct terminologies of context, context window, and tokens. Next lesson, I will be talking about how GPT understands the meaning of each word. Thank you.